Students, today we discuss a new one, that is thermodynamics. In the earlier chapter, you know what is temperature, what is heat. So based on this, we discuss thermodynamics. So what is the meaning of thermodynamics? Thermodynamics deals with temperature, heat and their interconversion, or we say conversion of heat into mechanical energy and vice versa. So one can write it deals with heat and temperature, and also there is conversion of heat into other form of energy. Conversion of heat into mechanical energy and vice versa. I mean, heat is converted into mechanical energy and mechanical energy is converted into heat energy. So thermodynamics, dynamics means in motion, and thermo relates to heat and temperature. In this thermodynamics, there are some terms used which is important for us to know. What are these terms? Suppose you say a system, that is a thermodynamic system. So what is that system? System means it is a collection of particles or molecules. Suppose you consider gas. Gas is a system. This gas consists of number of molecules. So system is nothing but a collection of particles or molecules. So what I write? This is a collection of particles or molecules with certain value of pressure, volume and temperature. With certain value of pressure, volume and temperature. So this is a system. Suppose we say our home is a system and we, the members, are the molecules. So in a gas molecules are the particles which gives a system. So gas is a system. Like that, a surrounding is there. What is that surrounding? Surrounding means what? Everything outside the system. I think everything outside the system. Suppose I am inside this room and the outside is the surrounding. That means we say the outside of the system which has a direct effect on that system. I am here, I am inside this room, someone is shouting outside this, so it affects me. That means this is the surrounding. But if one louds at a distance of 100 km, so this is not my surrounding. Surrounding means that outside the system which has a direct effect on me, that is what your surrounding. So what I write, that is outside the system which has direct effect on the system. So that is what your surrounding. I think you understand what is a thermodynamic system and what is its surrounding. If we consider a container like this, suppose I take this is a container. Here is a piston. This is what a piston. This is the container or vessel what it is. Gas molecules are inside it. Gas molecules are there. So this gas is a system and this piston is a surrounding. So you know what is a system and surrounding. They have important role in thermodynamics. Next part is your thermodynamic variables. Students, in physics there are so many variables like your distance, displacement, speed, acceleration, etc. But what is this thermodynamic variables? Like your pressure, volume, temperature. These are known as your thermodynamic variables. So what is this thermodynamic variables? One can write pressure, volume, temperature, that are used to describe the behavior of a gas. I mean, gas is a system. So to describe the nature of that gas or behavior of the system, you need some quantities, and these quantities are your thermodynamic parameters, or you say thermodynamic variables like pressure, volume, temperature, etc. So like that, another we need in thermodynamics, that is your equation of state. That means, what is the state of a gas? A gas is in which condition? What is its pressure? What is its volume? What is its temperature? So that state is described by an equation, and that is what your equation of state. So what is the equation of state? Mathematical relation between pressure, volume, temperature of a thermodynamic system. So what we say, equation of That is what? Mathematical relation between pressure, volume and temperature. Pressure, volume and temperature of a thermodynamic system. Thermodynamic system. So this is what your equation of state. Students, you know kinematic equation, you know other type of equation. So equation is required in physics to describe the position or the motion of the object. Exactly in thermodynamics you need what is the state, and the state of that thermodynamic system can be represented by an equation called equation of state. So how can we represent that equation of state? If I write an equation, you see, suppose I write PV is equal to nRT. So if PV is equal to nRT, P is the pressure, V is the volume, R is the gas constant, T is the temperature in absolute scale or Kelvin scale, and N is the number of moles, or N is used for moles. So this is the equation of state. PV is equal to nRT. So these are the terms needed to represent thermodynamical system. Also, in thermodynamics, some other terms are there, like your thermal equilibrium. So what is this thermal equilibrium? Suppose you take two bodies, A body, B body, you take two bodies and come in contact. So when two bodies are coming to contact, so what happens? That is, heat flows from one body to another body till temperature becomes same. So when temperature becomes same, this is what your thermal equilibrium. So what is that thermal equilibrium? You can say two systems are said to be in thermal equilibrium when they have same temperature. So what is this thermal equilibrium? That means when two systems, thermodynamic systems, when two systems come in contact, or you say when two systems come in contact, heat flows from one to another, one body to another body till temperature becomes same. And this is what your thermal equilibrium. Suppose I say these two bodies are in thermal equilibrium, means what do you understand? Yes sir, they have same temperature. So that is your thermal equilibrium. Suppose I take this diagram for understanding. You see, here is a container I take. Here is system A, here is system B, here is a interface, or you say separator. Suppose this is insulator. These are insulators. This is a system. This is a system. So in this case we say these two are not in thermal equilibrium. Suppose A has a temperature, B has a temperature, but there is an insulating wall. So no heat flows from A to B or B to A. But if this is your conducting wall, this is your conducting wall, or you say dithermic wall, you say this is your dithermic. So if it is a dithermic wall, so what happens? Heat flows from A to B or B to A till both have same temperature. That means A and B will be in thermal equilibrium. I think you understand what is thermal equilibrium. If A is a system, B is a system, it has temperature, it has different temperature, they are in a container, here is a dithermic wall, then heat will flow from this part to that part till both have same temperature. When both have same temperature, they are in thermal equilibrium. Next part, students, your thermodynamic equilibrium. One is thermal equilibrium, another is your thermodynamic equilibrium. What is the meaning? What is the meaning of thermodynamic equilibrium? For a system to be in thermodynamic equilibrium, it should be mechanical equilibrium. Means there is no unbalanced force. It is in thermal equilibrium. Means all parts of the system and the surrounding have same temperature. Another is chemical equilibrium. The system does not undergo any spontaneous change in internal structure, that is nuclear reaction or chemical reaction. Of course here it is chemical reaction. Then we say a system is in thermodynamic equilibrium. Suppose students, I consider here gas molecules. Here is a piston. So you know this is system, this is your surrounding. So if this system is in thermodynamic equilibrium, means there is no unbalanced force in the interior or between the system and the surrounding. In the system and the surrounding there will be no unbalanced force. Means force is always balanced. There is no chemical reaction in it. So this is your chemical equilibrium. Also between system and surrounding temperature is same. So this is your thermal equilibrium. So for a system to be in thermodynamic equilibrium, three conditions must be satisfied. One is there should be no unbalanced force between system and surrounding. Same temperature should be maintained between system and surrounding, and also there is no chemical reaction. So this is what your thermodynamic equilibrium. And the last part of this lecture is your zeroth law of thermodynamics. What is zeroth law? Zeroth law of thermodynamics. Students, one raises the question, sir, why zeroth, why not first law, why second, third and so? Students, first law of thermodynamics is there, second law of thermodynamics is there, but this is called your zeroth law. Actually, the concept of this law was developed after the first law. That's why first law is not changed and take it as zeroth law, because this should be developed before first law, but it was developed after first law. That's why first law is not changed, that name is first, so that's why it is your zeroth law. What is that law? In math, you know, A is a variable, B is a variable, C is a variable. If A is equal to B, A is equal to C, then B and C are same. That is in math. Exactly. In thermodynamics, or what zeroth law states, A is a system, B is a system, C is a system. If A is in thermal equilibrium with C, B is in thermal equilibrium with C, then A and B are also in thermal equilibrium. This is what your zeroth law of thermodynamics. What? Suppose I take A is a system, B is a system, C is a system. If this is in thermal equilibrium with C, thermal equilibrium, this is also in thermal equilibrium with C, then A and B are also in thermal equilibrium. This is a statement. What it states, if two systems A and B are separately in thermal equilibrium with another system C, then A and B are also in thermal equilibrium. If this is explained in a figure, suppose here is a container, here is a system, suppose this is C, this is A, this is B. This wall is dithermic conducting, this wall is dithermic conducting. Dithermic means, students, conducting wall, but this is your insulating wall, or you say adiabatic wall. Adiabatic wall means there is no heat exchange between them, so you say insulating or adiabatic wall. So what happens? A is in thermal equilibrium with C because there is heat exchange between A and C because of this conducting or dithermic. B also there is heat exchange between B and C. So what happens? If A is in thermal equilibrium with C, B is in thermal equilibrium with C, then automatically A and B are also in thermal equilibrium. See, there is no heat exchange between this and this. It is not possible due to this adiabatic or insulating wall, but they have or they are in thermal equilibrium. This is what zeroth law of thermodynamics. A is in thermal equilibrium with C, B is in thermal equilibrium with C. Automatically A and B will be in thermal equilibrium. So what is the importance of this zeroth law? This gives an idea about temperature. Why this gives an idea about temperature? Because that quantity temperature, or due to this temperature difference, heat flows from one part to another part. So we say the concept of temperature is obtained from this zeroth law of thermodynamics. So students, you understand what is this thermodynamics, basic concept of thermodynamics I have given. You understand this.